The topic of this third week of our course for our research is structure. So we would like to know what is the relationship between structure and the resilience of a building. As you know, structure is probably one of the most important topics and one of the most critical parts of a building in order for it to be resilient to natural disasters. So for example, structure is super important for areas that are affected by earthquakes, because the structure is obviously what holds the building, and when it starts shaking, if it's not designed in a proper way, then it falls down. Structure is relevant in places of flood, whether the building is raised above ground or below ground, it has an enormous difference. And also, depending on the material of a building, if it's made of steel, wood, or concrete, it is affected in different ways. The wood can be damaged irreversibly sometimes in times of flood, so the whole building has to be demolished and taken in and replaced. The structure has to be replaced, or the parts of it that are damaged, or it has to be dried. In cases of buildings made out of metal structure, the steel of the structure can oxidate because of floods, or it could be damaged because of, let's say, salt that's inside the water if the building is near the ocean or sea. So that's why it's very important to protect the structure of a building. We would like to know what kind of structures you have found, whether in vernacular buildings or in contemporary buildings. Maybe in vernacular buildings, most probably you'll find buildings made out of wood or buildings made out of stone or bricks, and then we want to know how these buildings react to the specific natural disasters. All right, so how does each material respond to the challenges of specific natural disaster? In areas that have been affected by typhoons, again, structure is critical. 2 years ago, we had the biggest, the strongest typhoon in history in the past 100 years, the Typhoon Haiyan in the Philippines, with winds that were more than 300 kilometers per hour. And obviously, in a wind like this, you need some really strong structure to withstand the lateral forces of the wind. Okay? Usually structures are designed for gravity, and they have to carry the weight of a building, but in some cases they have to also respond to the lateral forces of the wind. All right? So in these places of typhoons, the lateral forces, in fact, sometimes are stronger than the vertical forces. And the same is also true for towers. Okay, when we are talking about a tall building, lateral force is really important for calculating the building and for making sure, taking it into account, making sure that the building does not collapse when there is a strong wind coming from the sides. So these are briefly the topics that we're focusing on in terms of structure. First of all, what are the materials? Second, what is the response of those materials to the specific natural disasters? Third, how is the structure affected by a natural disaster, and if it's damaged, how can it be either replaced or fixed after this natural disaster? We also would like to know something about the details of the structure, how, for example, pillars and beams are combined, or how a load-bearing wall is combined with the horizontal structure of beams, or maybe a slab itself. So you can decide, well, ideally you're working both on a traditional building and also on a contemporary building. So if you look at your case studies, you can decide which kind of structure you're focusing on, and then present to us how it is affected by natural disasters.